talked about is about the packages, how to create the packages, and what is a package specification and what is a package body. All those things we have discussed. So we did understand that for always we have to compile the package specification first and then go by the package body or something. So similarly, when you see that what are the advantages with the packages is that advantage with the package is that, like, say whenever you invoke it, entire package contents will be loaded into the memory. If you are keeping the any function or a procedure in the package, it will be faster in executing and faster in accessing rather than creating it as a standalone procedure. So that's a simple difference. Like whenever you want to access any function or a procedure, always will prefix that with a schema name, package name, and then bring it. Let's say if I want to access the check salary function, which I have kept as part of my package. So let me go to that and then show you the check salary function, which is a public function which I have defined in the specification. So if you just see here, let's say this is a check salary function which is a part of your package, and this is a public one. When you say public, it can be accessed from anywhere within the database. So how can I access this package? Let's say I want to invoke that from my SQL statement. So let's say the last name, and you have a salary, and you want to talk about the checking of the salary. Let's say the my first package dot check salary, and which is a combination. I mean, this we are passing it as an employee ID. See, here I am showing you an example. How can you invoke the packaged function from the SQL? So when you try to do that, it's basically you're passing the employee ID and then checking a salary, whether it is an average salary is greater than the actual salary of that employee. So when you try to execute, it basically gives you that. So if you want to access the procedure which is a part of your package, so that also will always prefix the schema name. If you want to call the packaged procedure, how do we call is, let's say my first package dot delete student, and you invoke it. So let's say if you want to pass student ID 100, so this, if you like to modify, so this you can verify it. So basically you need to check this, and so if you want to call the packaged stored procedure, we are going to prefix the schema name. This should be a public procedure if you want to call it from the outside the package or from the any other package. So if it is a private procedure, you can refer within the package. Now let's say this is like a private, if I go to the body of this my package body, so if I go, this delete student is present in both the things. So if you see here, there is a symbol. I don't know, I think there is a symbol which not this one. Okay, yeah. So if you take a look at it, this add student is present only in the package body but not in the package specification. So this procedure, can I call it from outside? No. If you're trying to call it from the outside, it throws the error saying that package, this can be accessed only within the package, and if it is a public one, it can be accessed from any other package or any anonymous block which it can be accessed from. So that is the another thing that you have to understand by using the packages. See, basically there are different other advantages, overriding, overloading and all. I'm not going in much detail about it. So let's talk about the Oracle supplied packages in application development. So basically I said in the last class when we talked about, there are some Oracle application library packages or APIs, which we call application interfaces, which will be available in Oracle PLSQL library. So whenever you want to work with any kind of a file related, whenever you want to read the data from file, or whenever you want to write the data to the file, whenever you want to perform any file operations, then Oracle provides you the package that is called as a util file. This is just like your DBMS output. Util file is also another API which it is there. So whenever you want to know what kind of packages it is having, always you can right click and then use pop-up describe. It basically opens up the complete methods, complete functions which are part of it. And similarly, if you want to know about, in the last class also I've shown DBMS output. So DBMS output is another package which it is there. And similarly, DBMS util underscore mail. Whenever you want to send a mail from the stored procedure, you want to send a mail from a stored procedure, then we will use it. And DBMS lock, whenever you want to lock it, or whenever you want to schedule any program, we'll go for DBMS scheduler. All those things we'll use it. And one important thing, another API that you have to know is the DBMS underscore SQL. So this is actually used to handle the native dynamic SQL. So we'll understand what is a dynamic SQL and how it is different from the normal SQL. So we are going to call it as a native dynamic SQL. Whenever you want to execute any DDL statements, we'll use DBMS underscore SQL package. Execute any DDL statements. So this we will use it. So this is how we basically use it using the dynamic SQL. So now there are various supplied packages. There are so many packages which are available. So if you want to know what are all the supplied packages by Oracle and which this user has access to, you can always go to all objects, and in the all objects you can query the object, not object name, basically the object type, where owner equal to sys, owner equal to sys. If you want to know the list of APIs, which are list of APIs, and I want to know all the packages which is a PLSQL library. Basically we are talking about Oracle supplied packages. So if you want to know where object type equal to package, right? So sorry. I don't know. I'm just trying this out. Okay. This one is your object type, which is equal to this, and then try to execute this. So these are all the different packages what you have. So if you see the count, how many packages are available. There are total 220 packages are available just on Oracle APIs, which helps you to perform the different kind of programming. So these are all the different Oracle supplied packages which are used in development. As in data warehousing project, you might come across the DBMS SQL, and other than that you don't come across any other APIs which you require. But anyway, in the PLSQL you have more than multiple APIs which are present in this. So I'm more interested, because so far whatever we have discussed is just for an introduction. I'm more interested in explaining you about how the dynamic SQL is being used in the data warehousing environment. In order to understand the dynamic SQL only, we have actually spent three classes to understand the complete basics about your PLSQL. See, basically a dynamic SQL, which means let me open a new sheet. We'll start writing in that. So dynamic SQL is basically when you talk about the creation of procedures and functions. In that procedures and functions, you can write only the DML statements in the procedure. You cannot write the DDL statements like a drop, create, alter, these kind of DDL statements cannot be referred directly in any procedure. You cannot refer them directly in any procedure. Now we are going to understand how a DDL statements can be embedded using the dynamic SQL. So basically the dynamic SQL can be processed in two ways. One is working with a native dynamic SQL, that is using your execute immediate option. So there is something called as a native dynamic SQL, and another is called as a DBMS underscore SQL. So basically by using a package also you can do the same process. Execute the DDL statements and all those things by using a package also. Or if you want to process this native dynamic SQL, Oracle provides you another option. By using the keywords execute immediate, you can actually you can basically execute all the DDL SQL statements or whatever. So I'm not going in much details about how the DBMS underscore SQL is being used. I don't want to put you into the confusion with a lot of concepts here. It's a very simple way of understanding the dynamic SQL is by using a execute immediate. So how an execute immediate works and how can we write a simple programs using an execute immediate, that will understand. Let's say now my first dynamic SQL that I'm going to write. So I just want to create one index on a particular column. So let's say I have assume that I have a table name and the column which I'm supposed to create on the create, and also the type of index what it is. So what I'm trying to say, I have a table, okay, called as, let's say, DB indexes, so which we call it as a DB indexes. I'm creating one table. So basically create table DB indexes. So this table will contain the details like table name, on which table you are basically creating the index. So when you see this varchar 2 of varchar 2 of 100, let's say index name, basically you have the index name also varchar 2 of 100, or which column you want to define, column name of the table. So on which column you want to define the index. So basically column name is, so varchar 2 of let's say 100 again, and what else, type of index, which type of index, whether it is a normal index, function based index and all. So this is also varchar 2 of 100. I'm just creating a table just to store the information about what tables have to be created. So, and I have a column like create date. Create date is nothing but when this record is created in the database. So I'm creating one table called as a DB indexes. This table will contain the list of indexes which I'm going to create on my target tables. Okay, so let me create this DB indexes table. So there is a lot of concepts which are involved in this. You need to be concentrated in the class. Okay, so now I am going to add some indexes. So let's say insert into, let's say DB indexes, let's say values. I'm going to, I would like to create a index on a table called as a student. Let's say that is my requirement. So let me go to table list, and I have something called as a student, and I want to create an index on the, let's say basically this is a unique index that is being created. I would like to create index basically on the name column. So if you see, we have 3 different columns. I want to create this on the student name column. Okay. So what I do is, table name is going to be student, and the index name, let's say I define the index name as IDX underscore name. Column name is going to be the name column. So you didn't, sorry, I don't know, it's a name or student name. Yes, it's a student name, column name. This is a column which I want to create an index, student name, and the type of index is a normal index, so not worried. So the normal index, and the created date is a system date. So sys date, which it is there. So try to do this. Now row is inserted. Let's commit the data. So now the data, if you try to query the DB indexes table, if I try to query this DB indexes table, select star from DB indexes. So when you try to query, this is going to be this one. See, now what my requirement is that I have a table wherein the list of indexes supposed to be created on those tables. I'm adding that onto a table called as a DB indexes table. Now my requirement is that I need to read the list of indexes. I need to read the list of indexes to be created on that table, and then create that index on a particular table, whichever it is. So basically I'm going to define a stored procedure which will take the table name as an input and create all the indexes which are defined in this table. I hope I'm clear here. So what I'm trying to tell you, suppose on a student table, if I have 10 indexes which are supposed to be created, my procedure, when I pass the table name, it will read all the indexes from this table, and then it will create that index on the particular table. So here I'm going to write a procedure which will create the indexes for me. So basically by using a dynamic SQL. So why we are going for a dynamic SQL is because we cannot use the DDL statements directly in the stored procedure or a function or in any package. So now I'm creating a procedure. So create procedure, and name, this is going to be the create index. So I'm going to call this as a create indexes, or you can call it as a indexes. So what it takes a table name as an input. So to which table, on which table it has to create the index. So let's say varchar 2 of, let's say 100, we cannot define it, sorry, varchar 2, and another one is error out. Let's say the error message which it is there, and out, and let's say you have it as create indexes, and when you go here, let's say you have it as an out, and this is also of a varchar 2. So is basically what this procedure is doing, it is taking the table name as an input, and it has to create all the indexes supposed to be created as per that DB indexes table. So here, in order to retrieve all the indexes, so I'm going to define few variables here. I'll tell you why it is required. I'll define a variable called as a VSQL, which is called as a varchar 2 of some 4,000 or some 32,000 or something, which you can define. And we also need index name and all, not required. Let's try to use the, let me use the index name. Basically this is also of varchar 2 of 100, and I also need a table name table name on which we have to create. So I need another variable. I'm just defining that as well. If any variable is required, we'll come back here. So what I'm doing is basically I'll go and retrieve all the indexes which are supposed to be created from this DB indexes. So how can I get the list of records here? By using a cursor. So I'm defining the cursor. So I call it as cur underscore indexes. Cursor underscore indexes is, so what I need from the DB indexes table, basically I need a table name and I need a index name which is supposed to be there, and I also need a column name. So I think we are clear here. Table name, index name, and the column name which it is required. So I'm pulling all the columns. I'm pulling all the records. So basically it should retrieve me based on the DB indexes. So it should retrieve me the based on the table name. So I'm going to write it as where table name equal to p underscore table name. So I think that since the table name is same, you don't need this, and basically this one, instead of a table name, you can directly write it as a column name which it is there. Now what I do, this cursor is giving me the list of indexes, so I'm going to write the statement creating the indexes in a loop. So if it returns more than one record, then I have to go to the within the loop, right? So within the cursor. So for indexes or ind create or something, just ind in what is a cursor which we are going to loop through. This is a cursor which we are going to loop, and then the end loop here, and then the end loop. So when you take a look at it, I just want to prepare the first VSQL, because you can try and write a DDL statement directly in a procedure or a function and try to compile it. It will never get compiled. So v underscore SQL. So what is the syntax to create an index? So for creating an index, this is the syntax that we follow. It's like create index name, create index. You're going to provide the index name. Index name is dynamic for us, and index name, and then on, and it is going to be the table of column name. So that is what it is going to be when you see this table of column name, what it is there. So let's say if I want to create an index, so I am going to use it as create index. You need to mention that in the single quotes. It's completely, it will treat that as a string first of all, and there is a space, and when you concatenate, you need to provide the index name. So how would I get the index name? You're already retrieving that index name. So here I can use it as v underscore index name is equal to ind dot index name. ind dot index name, which it is there. So the next one is the another one, that is your column name. So v underscore column name. So the next one is about ind dot column name. So this is what we do, right? So ind dot column name. Now the index name is there in the variable and v column name is there here. So I want to mention the index name as is and concatenate with this. So space on. So what is a table? Table is again a dynamic. So table name is going to be the dynamic one. So what is the table name? You're passing it as an input. So I can directly use it. So table of. So basically you're going to again use the parenthesis. So what is the column name that you're going to use? So this is column name should be mentioned within the parenthesis, right? So v column name. Again, to close it, again you need one more concatenation operator. So basically this is how it looks. So if you try to completely replace, so take this and replace whatever that we have mentioned it here now. So your statement at the runtime will be converted. So something like this. So table name, create index. So IDX underscore name is a index name, and this will be converted as a table name. What is a table that you have defined? Student. And column name is going to be converted as a student underscore name column. So this is how at the runtime your statement will be converted. So that is what I have written here. That's it. So create index, v index name will be replaced with a index name retrieved from here, and the table name will be replaced and the column name. So this is how it will do. And I'm going to print this just for our understanding how the DBMS v underscore SQL is prepared. So I just want to print it. So let's say if you want to print VSQL, how it is there. So let me just print the VSQL value. So this is just for our understanding. Now we have this VSQL statement. So how can I execute? So that execution will be done by the execute immediate, which it is there, and execute immediate VSQL. So I want to execute this SQL. So whatever the dynamic SQL that you want to execute, you just provide it. It will just execute and create it. So basically what this procedure is doing, whenever it will read all the indexes which are defined in my DB indexes table, and it is looping through one by one, and then it is looping through one by one, and it is creating the indexes. So when you say exception, let's say when others, then when others, then let's say you have, whenever there is an error, I want to assign that error output message on this. So p underscore error out, which is equal to, let's say, SQL ERRM. So I want to throw that error message whenever some error happens. So what we are doing is, for creating the indexes, we have defined one metadata table wherein we'll add all these things and then do it. Okay, it's a big error we have got. Okay, let's see. Let's go back and understand one by one in which, okay, let it be anyway, it's compiled, but there are errors, right? Okay, let me take a look at it. All right, so missed a colon here. All right, thank you. So try to already used by an existing object. Yes. See, now I have compiled the stored procedure. When I'm trying to compile one more time, it is throwing me the error saying that it is already used by an existing object. Why? Till yesterday, I have used the option as create or replace. Now I'm using only the create procedure option. So what is difference between a create procedure and create or replace procedure? Basically what happens is that create or replace means if the procedure is already existing, it will replace it. If the procedure is not there, it will create it. That is the meaning if you use a create or replace. If you are using only create, it will just it is just that it will call it, it will just try to create it. Now let me compile. Still we have errors. Encountered, what is that error? 19.5 v column name. Yes, thank you. So let me try to compile it again. I think it looks like this time it's compiled successfully. Let me go back and check whether this procedure, I can see here whatever is compiled. So basically, where is my procedure? This one, and I have something called as a create indexes. So what I'll do, I'll just keep this procedure as part of my package. Instead of keeping that in the standalone, I want to keep that in the package. So let me add it. If I'm adding it here in the functional spec, if I'm adding this in the functional specification first, that means that's a public procedure, and I'm going to add even the body as well. So now whatever is there, I'm just copy paste and then add it in the code. So if you go here you're going to add check indexes, create indexes. So let me compile this as well, and now it is compiled. So whatever the procedure that we have created, that I've kept it as part of a package. That is my first package. Okay. So now I need to test this by passing the table name. I need to test this whether it is creating the indexes for me or not. So how can I execute a stored procedure? That's from the anonymous block, testing the create index procedure. So what I'll do, I'll use the I need one variable for testing this. So one is declare. Let's say v underscore, you have the some error message. Let's say I have an error message, and you have it as varchar 2 of 1000 or 4000, in fact 4000, and let's say begin and end. So I want to invoke this packaged stored procedure. What is your package name? It's basically package name is my first underscore pkg. So let me write my first underscore pkg dot create indexes. So I want to pass the table name. Now I want to pass the table name as a student. Student is my table name, and it has to create the index on that. So the next one is your going to be the v underscore error message. So this is your v underscore error message. In case if it is an error, I just want to print it. Print dbms output dot put underscore line. So that error message, I just want to print it. So basically what we are trying to do, when I pass this table name as an input, it will create an index on my student table. So let's go here to the SQL part, and then even on the, when you go to the table level, you have something called as a student, right? So if I go to indexes, how many indexes are there here? 2 indexes. When I execute my program, if my program is successful, there should be one more index which should present over here. So let me try and execute that program now. So when I do this, so it basically has to create it. So it says that resource is busy, acquire with no wait. There is an error when it is trying to create an index. It is throwing the error as resource is busy and acquire with no wait specified, and this is an error it is throwing. But syntax wise, I don't have any issues. I think create index name student on a student name. Why is it so? Which is the other table who are accessing this? I have. Okay. I'm not sure if somebody is accessing this student table. Maybe they might be adding some data or something, and that is the reason it is throwing me. It is not allowing me to create. Why we have got that error is because when it is trying to create an index, your Oracle is not allowing it to create. Oracle is not allowing it to create, and it is throwing the error as resource is busy and acquire with no wait specified. That's an exception that which you are getting. So let me, what can I do now? Can I try and create?
Karthik,
Yeah.
Karthik, I have a question. So I created the similar thing and what is happening is, consider first I created two rows. First row is employee number, second row was for index for employee name. What is happening is, employee number already there is a primary key and it is throwing an exception where such column list already indexed. So what is happening is, it is not going to the second row to create an index for the employee name.
It will
So in
not
such
go.
scenarios, how we can do that?
If you want to handle it, then you need to have a nested block inside your program.
Okay.
So within the begin itself, it's a little advanced thing in a programming in the PLSQL. So what you have to do is, you can write one more nested statement, begin end,
Okay.
and you can have an intermediate exception here.
Okay.
So basically what happens, if something runs here, it will go to this exception first and then continue from here. So if you have an outer exception, once it comes here, your control is already gone out of it. I mean, it will come out of the program. So if you have to handle such scenario, you need to go by this. Okay.
You need to create another begin. Okay.
Yeah, another begin and end. Within the loop, you have to handle that.
Okay, got it. Yeah, makes sense. Yeah.
Yeah, this is an issue with somebody might be trying to access the same student table who is using the HR schema, and it is not allowing me to create an index. So what I do now, without a confusion, what I'll do is I'll go and add for another table maybe, and we'll try to create an index. So let me take another table. Which table I can use it? Which table I can use it? Okay. Okay, let's go for regions table. We have only two things, and there is already one index which is there. I'm going to create one more index on the region name. So let's say regions is a table, region is a name, and let me add index. Basically, in order to proceed, if you have to create an index first, you need to make an entry into this DB indexes table. If there is no entry in the DB indexes table, your procedure will not work. Okay, so these are all something little advanced. I'll tell you when we go to the I'll tell you what is required to be done in the warehouse environment in the basically when we go to the Informatica Power Center concepts. So that time you'll come to know why we are doing all this. For now, just understand the procedure to create the indexes. So regions, and I call this index name as IDX underscore region name, IDX underscore region name. Let's say this is a normal mode, and then this. So let me try to create this index. Row is inserted, and then you commit it. Now what I'll do is, since when I'm trying to create an index on student table, it is throwing me the error. That's why now I'll try to create a index on the regions table. So in order to test this, it's the same thing. All you need to do is that just pass the table name as different, isn't it? So when I go here, use regions, and when I try to execute, basically now on the regions table, it has to create one more index on the name column. Let me try to do that. Okay, this time it is succeeded, and it should have created an index on this table. Let's go and refresh. So this is an index which is created through the procedure. I have created this index through the procedure, and now it is appearing here. See, basically why I'm showing you the create indexes through the procedure is that when you go to the data warehousing environment, you have to do this creation of indexes and dropping of the indexes through the procedure, and you have to invoke that from Informatica Power Center. So that is the reason I'm showing you how can I create an index through the procedure when I have a list of indexes to be created in a particular table. So this is an example to create an index. I hope you must be having a lot of questions here. So I'll wait for your questions for next 5 minutes and go over it. Yes, let me know your questions if you have any questions, or if you have even a confusion also, let me know. I'll try to be. Yes.
Karthik, it worked. So
Okay.
what I did is after the VSQL whatever query we have printed, I gave a begin block. After that I put execute immediate. In that I put exception. After that I ended, After that, I put this end loop, and that's how it worked.
Yeah, it will work definitely.
Yeah, thanks.
Yeah. See, what we are actually trying to do is, let's say I have one metadata table. I'm calling this as a metadata table. You'll understand what is metadata is all about. What I have done is, I have created one DB indexes table. I've created one DB indexes table. In this DB indexes table, I'm adding, suppose let's say I have some 10 tables. On 10 tables, I have to create some 5 indexes. Each table has some 5 indexes, and for whichever the indexes that you want to add for that table, basically I have added a record to it, saying what is a table name, what is a index name has to be created, what is a column name, what is a type, and everything that I have created it. Now your program, what your program has to do, your program has to read the list of indexes to be created from this DB indexes table based on the table name. So when I'm defined my program, what I've done is I've passed the table name as an input, and whenever if it returns any error, I want to capture that error message on the p error out. Okay. So what I've done is I'm reading all the index names and the column names to be created on my based on my table name here, based on my table name. So when I use this, it's basically, it is giving me all the indexes and the column names where I have to create the index based on my table name. Then later on, what I'm actually doing is I'm looping through the each and every index. See, there might be a case that on one table you might have to create 5 indexes. So that's the reason I'm actually looping it, and I'm getting the index name and the column name into my, I'm getting the index name and column name into my 2 variables, and I'm using a dynamic SQL here for preparing this. Why do we need to use this? Why can't I write directly the statement saying that create index and you do this? So basically what happens is that you cannot write a DDL statements inside a procedure or a function. That's why I'm using, first I'm preparing the statement, DDL statement, based on the table name, index name, and then the column name. Okay, so I've done that. Then I'm using DBMS output dot put underscore line. This is, that's why I think probably it is not printed. It is just put into the buffer and it is not printed. Okay, it's DBMS put underscore line. I'm printing that message, and I'm using the statement as execute immediate VSQL. So whatever that create index statement is there, it will basically executes it and it will create the index for it. So in this way, it will try to create the indexes in, it will basically use the indexing option, and then it will create the indexes for you. So that is more about the how do we create the indexes using the stored procedure. All right. Any questions here still? I think probably this is a little advanced concept. If you still have little confusion, probably eventually you'll understand why we are actually writing such kind of a logic inside a database procedure. Basically, we just understand how to write this procedure, and you didn't even still we didn't understand what is the use of it basically. So that is where still you might be having some questions. Why did I write it? So when we go to the Informatica Power Center, I'll tell you why we require such that kind of a procedures in a data warehousing environment. All right. Clear or confusion in this? Okay. In Informatica, do we create the tables and insert the data into the tables? One thing is that using Informatica, we don't create the tables. We insert only the data into the tables. It's just a ETL tool, right? So L means it's a load. It will load the data. We'll understand what is an Informatica is all about probably from tomorrow, or no, from the next week. So tomorrow we'll talk about data warehousing concepts and all those. All right. So this is one stored procedure which I have written using a dynamic SQL. Let's say I want to write another stored procedure to write the procedure to analyze the tables. Procedure to analyze the tables. So can somebody tell me, like, if you have an idea, what is the need of analyzing the tables? So basically what happens in the real time is that whenever you load the data into the tables, if it has to, whenever you're querying it, if your query has to be performed better, then what we do is we analyze the tables. Analyzing the tables will store the statistics in your metadata tables or in your execution tables, basically the cost oriented tables and all. Analyzing the table will collect the statistics and store it in the data dictionary. So whenever you write a query, basically it will retrieve the data faster. So you can think in that way. Analyzing the table will help you to collect the statistics about that table, and those statistics will be stored in the data dictionary. You cannot see those, what kind of statistics it is storing and all, because that is confidential to the Oracle database. So you cannot see that. In the real time, what happens is that whenever you have issues for analyzing the data, whenever you have issues for reading the data and all, we analyze the tables. At the end of every program load in data warehousing, we analyze the tables. So analyzing the tables will improve the data retrieval process, just like your indexes. Now you can try and read more on what is other way of understanding your analyze table. You can analyze the table, you can analyze the schema, anything. So let's say now I'll pass the table name. Basically it has to analyze that table and then do it. Okay, so let me create a stored procedure again. So create or replace procedure. Let's try to write this time directly in the function, package. I don't want to write it in the standalone procedure. So what I'll do is, it's a similar kind of a thing. I want to analyze that table name, and this I call it as analyze table, and the table name, and then the error message, all those things. And basically if you try to see this message body, I'm going to write it here, because basically I'm creating anyway the public stored procedure is, so begin and end. So what is the end? Analyzing the table. Analyzing the table is also one more activity that you do in the data warehouse. Okay, so let me try to use again a VSQL varchar. So varchar 2 of, let's say, some 4000. I'll just pass the table name and it has to analyze it. Okay, so only one table I'll pass at the same time. I am not going to pass the multiple table names. So v_SQL, and here you have a analyze table. And what is a table name? Table name is going to be your p_table name. So just pass it and execute immediate. VSQL. And I need to close this, and similarly I need to add this exception block, which is very similar to this. So basically first I have to compile the package specification. Let me compile it. Yes, it's compiled. And the next one is to compile the body. Okay, this analyze_table declared in the package specification must be defined in the package body. So what is error here? Analyze_table, which we have defined it as varchar2 and varchar2. Where did it go? Oh my god. Control Z. Okay, I think it is gone. Maybe I think I have not captured it properly. Anyway, we'll just quickly finish it off. So what is analyze table and analyze table, and the exception is going to be the same. And here you have a begin, v underscore SQL is to analyze the table, and let me pass the table name what we are passing it as an input. And just for our understanding, let me print this one, how dbms output dot put underscore line v underscore SQL. So let me just compile this. Compiled with errors. It's compiled. Now I have to invoke this. I just have to analyze. See, basically I cannot actually show you whether it is completely analyzed or not. If you have to, yeah, I'll show you anyway. I think we'll be having that in the user underscore tables. Okay, let me just try and analyze now the region. Yes, very good catch. I think I missed this. Execute immediate. Execute immediate. So what is that? v underscore SQL. Let me compile it again. So compile with no errors. Now I have to test this stored procedure. Okay, anyway that I have compiled it. So what I'll do, I'm going to paste this complete packages when I'm sending a mail today. Okay, you can keep those packages and try and write that in your programs. Okay, now I want to test it. Let's say I want to analyze the regions table. Let's use the same table, begin and end. So declare, so we call it as v underscore error message, which is of varchar 2 of 1000. And here I'm going to, it is actually a part of my first package. So I write it as my first package dot analyze underscore table. It is taking a table name as an input. So I'll pass regions as a table name. And another one is v underscore error message. So just it is going to be the v underscore error message. So try and compile this, whichever is there. So you're going to analyze the table. Now it is analyzed. So how would I understand whether it is analyzed it? So let's go. So select star from user underscore tables, where table name is equal to regions. Table name is equal to regions, and when you try to use it, here in this there will be a column called as a when the table is last analyzed. So it has analyzed as 13 September 04. Sometimes these statistics also doesn't change as properly. It is basically saying it has very long time back this table is analyzed, but the statistics what I'm actually retrieving is not properly basically this is not refreshed. Basically if you go and see, this data dictionary table would have been updated with the current date, but it is not updated for some reason. Anyway, so this is one way of another way of writing the PLSQL stored procedure for analyzing the tables and all those things. Even we can also try and see whether we can how to drop the indexes. Basically, the dropping of the indexes stored procedure will see that in the data warehouse environment when we go, and then anyway we'll again discuss that. So basically, these are all the things which I wanted to discuss mainly on the PLSQL. I wanted to give you the glimpse of what is dynamic SQL is all about and do it. So I'm pasting this package. So in case if you want to compile, you can compile and then keep it. So this is your package body. First you need to compile the package specification and then the body what it is there. So that's
Karthik,
yes.
Actually for me it worked like if I use analyze table name compute statistics, then only it was executing. Without just analyze table name, it is not working.
Okay, let's see that. Okay, 1 minute.
Yeah.
PLSQL dynamic SQL. What you're saying is here you have appended no, not here, sorry. Here you have used it as
yeah.
Okay, let me compile this and let's go back and test it again. Yeah. So this probably I think we need to mention that whatever that statement here, compute statistics, and that is where which we missed it. And even you can compile, you can add that in the package when you're compiling and then test it. Let me just add it here. Yes, sure. I'll send all these scripts to you so you can practice and then do that. No issues. Compute statistics. So this is more about the handling of your dynamic SQL in the PLSQL. And there are so many things which you have in the PLSQL is about the triggers, compound triggers and all those. I'm not going in detail about all the triggers and everything. Basically you're not going to use that in the real time. So one thing is that if your SQL statement is returning anything, you can use this kind of a into clause and using clause. Anyway, with the experience you'll again understand all about those. So that's it. I have it about PLSQL, what I wanted to discuss. And from the tomorrow's class, you're going to receive the new link, and we will be starting with data warehousing concepts. And if you get a chance, try to brush up on what is an OLTP system and how the data will be available in the OLTP system. So we'll get started from there from tomorrow. So I said you'll receive a new link from tomorrow. So please make sure that you check your mails and then log in for the class. Okay. So in case if you're not receiving a link, probably you can get in touch with the coordinators who have sent a mail to you. Okay. All right then. So that's it I have. If you have any other questions related to anything, I'll probably try and help you out now. Yeah. So what is a save point? Is basically the save point is it's a mark in a particular transaction. See, let's say you know that a TCL language is basically includes your commit, rollback, and another one is called as a save point. So what do you mean by a save point is that let's say if I am inserting data into some student table and I'm updating some data in the regions table, and I'm deleting the data from some student table, I'm deleting some student, and this a complete a transaction, like when you say a group of transactions like this, so on, uh, this, let's say you're updating some employees table, so this is a complete group of transactions. So this group of this group of statements is called as a transaction. Okay, so when you are processing this, let's say if I commit, what happens, it will commit every transaction processed with, every statement which is processed. If I say rollback, everything will get rolled back. But given a scenario, let's say whenever there is an error while updating the employees, I don't want to roll back the entire transaction. Basically, I want to roll back only this transaction, and remaining all the other transaction which I performed on the student table and the regions table, I want to commit that. So if you are issuing a commit and the rollback after updating the employees, it's basically rollbacks everything. So in case of any error, I want to roll back to the particular point in the transaction, I don't want to roll back the entire transaction. So what it will do is, let's say at particular point, I can actually save this point, save or mark up this point. I will create some checkpoint with the help of this. So when I'm writing the statement here, I'll write as save point A. Save point A. Any name you can give. It's not only the A or B. Any name you can give. So save point X. So this is your program. So basically, when you got an error in the update employees, basically you want to roll back, but I want to roll back only the update employee transaction. If I write roll back to save point A, roll back to save point A, so what it does is it will roll back till this, roll back to save point X. It will roll back to only till this point. That means only the transactions which are performed till here will be rolled back, and remaining all the other transactions you can still commit them. So what does that mean? Save point will help you to roll back the transaction to the particular point in a group of SQL statements when you're performing. You don't need to roll back the entire transaction. You can roll back only to the particular step in the transaction. So that is called as a save point. So whenever you are working with the parent and child tables, let's say you have inserted a data in the parent table, and when you are inserting a data in the child table, you got the error. Basically, if you want to commit the parent table and only the roll back the child table, so in that scenario, you can still go ahead and then the roll back in a particular transaction. So basically, the save point will help you to roll back the transaction to the particular point. So that's how this will work. Okay, so this is more on the save point in a PLSQL. All right, so any other questions from anyone? So okay, see what happens with the cursors is that whenever you want to process the group of records, you will go for a cursors. Okay, so here when you see the create indexes program, whatever we have written, this is basically why we have written a cursor, is because I want to process the multiple records. I want to process the group of records. That's the reason I have created a cursor here. So this cursor will help you to loop through the group of records. We wanted to process the multiple records, which I mean to say. Okay, so when you go here and then move on, basically I'm looping through the cursor. If my cursor returns 10 records, I have to create 10 indexes. If my cursor returns 100 records, I have to create 100 indexes. So the cursor is basically it's a pointer in a memory, Oracle server memory, which helps you to process the iterative data. When you say iterative data, it's nothing but a group of records. So that is called as a cursor. So cursor, when you see the different examples what we discussed yesterday and day before yesterday, it's that when you want to process, there are two ways to define a cursor program in a program. So one is by using a basic method wherein you have to open the cursor, fetch the data, close the cursor and all those. Or else, like if you want to process, this is the best way to define a cursor always. Okay, so always define a for, and IND is going to be it's just like a memory pointer in your C language and all. We'll write it right for I in 1 to 10. I is nothing but the iterative pointer. So even IND here is nothing but a iterative pointer. So if you have to access these columns, we'll always prefix the cursor name dot column name whenever you want to access it. So here we are looping through this cursor, and this is my variable, and variable name dot index name will give me the index name, variable name dot column name will give me the column name. So this is how it looks in this. So this is more about the cursors, like how do we implement it. So if you need any standard definitions when you want to prepare for, so this you can go over these fundamental documents which I have given. So based on that you can understand. All right, so that's pretty much I have for today's class. Any questions or anything? Still we have some time, and probably I'll just you can reach out. I think we'll send out a mail now. If you give me a time in 10 minutes, I'll ask the team to send out a mail. Your Informatica username, database username, passwords, everything will be sent to you in a mail. Okay, thank you. That's it I have.
Yeah, I think can you send us that practice answers?
Oh, one second. Let me